So this question is asking, sketch and identify the graphs of, and I see A is equal to 3x squared plus 4y squared, B is equal to 2x squared minus 5y squared. What I want you to notice is that in both cases, it's solved for z, and therefore I can write it as a function. So I can write z equal to f of x and y for both these cases. And there should be only one z for each x pair, x and y. Now, let's start with this one. What I want to do is, I know these are quadratic surfaces, and I start with x equal to k. So if I intersect this shape with x equal to k, I get z equal to 3k squared plus 4y squared, which is a parabola. And this is going to be always positive. It will look like this in terms of y and z. Now, if I do that same thing for that, and I get z equal to 2k squared minus 5y squared, this is again always positive, the first term, and the second term is a parabola looking downward. Oops. The shift is above. And then let's say for y equal to k, the cross section, for y equal to k, I get again z equal to 3x squared plus 4k squared. And that is a parabola looking upward again. So x and z will go like that. And over here, I get z equal to 2x squared minus 5k squared. And that is a parabola looking upward. X and z. It starts at a negative value going upward. And then it could be when k is equal to 0 in either case, it would start at origin. Now let's do, so these two both parabola looking upward. These two, one upward, one downward. And then I have z equal to k, then I will have k. Now this may change things. For certain k's, let's say k negative, k equal to 0, k being positive. So if I put in a k negative for z, that's not possible because two positive terms add up to something positive. Two bigger than equal to 0, two non-negative things add up to be something that is non-negative, so nothing for this one. If I plug in 0 for k, the only way two non-negative things add up to 0 is if both of them are equal to 0. So the 0.000 is the answer. For k bigger than 0, I have k equal to 3x squared plus 4y squared, and these are ellipses. Over here, basically, for k equal to negative value, so let's say k is 2x squared minus 5y squared equal to k and negative value. I know this shape equal to k, I mean difference of two complete squares equal to a number is going to be hyperbolas. I just have to figure out which hyperbolas. If k is less than 0, if I plug in x equal to 0, I can get a y value. So there are y-intercepts. For k and I have to draw an arrow. For k equal to 0, I'm comparing this row basically. For k equal to 0, I get 2x squared minus 5y squared equal to 0, which means x squared is equal to 5/2 of y squared. That is, x is equal to plus minus 5/2 y, 2 lines. Like that. X, what is remaining in this part is when y is equal to, so when z is equal to k and k is bigger than 0, then I will have 2x squared. And again, this goes with that one, 2x squared minus 5y squared equal to k bigger than 0. Here, if I plug in x equal to 0, I will not get any y value because a negative value should not be equal to a positive value. So, but if I plug in y equal to 0, I will get an two x values. So it looks like this hyperboloid. X, y. And so all of these together, and for the first one, for A, what happened is that I know I got parabola this way and parabola this way and a whole lot of other parabolas going the other directions. And then when I do, let's draw one z cross section. Looks like this, basically. And of course, it goes to infinity, but I'm just doing it all the way to one cross section. And this is called, again, going with the shapes that I got. I got 2 parabolas, and I got a point in here, which is here, and I got ellipses. So what you expecting is elliptic paraboloid. And over here, I got, what did I get? I get parabolas looking up and down, and I got hyperbolas. So you're expecting a hyperbolic the funky thing is that with the hyperbolic paraboloid, the direction from one direction to another, it looks like x and y. And if I'm going from x and y, and if I'm going from here explains in the cross sections when x is equal to constant, it's just looking downward like this. And then when I'm going into the y direction, it looks upward. So here is the mountain. And then I have these parabolas to telling me that when I'm going this direction, it actually goes that way. So it ends up to be a Pringles, basically.